Hello, this is just a tutorial on some programming problems from this code from Needs Code. So I'm just going to knock out a few of these and see how that goes. Okay, so on this one, we have to find if there's a duplicate. So we're given an array and we output if it's true or false. If any value appears more than once in the array. Okay. This one seems pretty easy. We're just going to use a set for this. And we're going to call it sorted. So all we're going to do is insert the elements into the set nums. Okay. And it could be as easy as just saying return sorted size is equal to nums size. And we'll return either true or false. So here we're going to go ahead and say if they are equal, then we are going to return true, otherwise false. And let's just try that. It looks like that didn't work for some reason. Oh, that's because I have these reversed. Okay, if they are equal, then it's false that we have a duplicate. And if they're not equal, then it's true. We do have a duplicate. So we can go ahead and try again. Looks like it worked. And then we try against other tests. Looks like it worked. Now we'll just go on to the next one. So here it says given two strings s and string t, return true if the two strings are anagrams of each other, otherwise return false. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Okay, for this one, we can use the sort function from the STL library. So I'm going to do sort s.begin. So the begin is an iterator, and then we're going to use s.end, and that should sort s. Then we're going to do the same thing, but for team. So I'm just prioritizing speed right now, and I'm going to return if s is equal to team, and if they are an anagram, they'll be equal, so we'll return true. Otherwise, we can just return false. Okay, perfect. All right, looks like that one is done as well. Solution was accepted. Now, on to the next one, which is twosome. So this one says, given an array of integers nums and an integer target, return the indices of I and j such that I plus j equals target and I is not equal to j. You may assume that every input has exactly one pair of indices that satisfy the condition. So this will never not be true. It's always going to be true. Return the answer with the smallest index first. Okay. Sure. Okay, so I'm gonna create a hash map for this. So the reason we're gonna use a hash map is so we can find the difference that we need to complete target at every one of these numbers in every different instance of the function. So I'll do int and then int again. I'll just call it m. And then we're gonna fill that map. And then what we're gonna do here is and we're gonna say target minus nums at counter. And then we'll create the counter here. So target would be, for example, 7, and then we're subtracting, for example, 3, which will leave us 4 as the key. And as you can see, 4 is right here. And we want to add the index. So there's our counter, and then we're just going to increment. Okay, sure. So now we have a hash map with each one of these, what they need to complete 7. So 7 minus 6 would be 1, and then 2, etc. And we need to find the index that we need. So now we're just going to iterate through the numbers. I'm going to create a size variable. Okay, so now that we have all of that, we can simply try to find the target that we need based on the current index. So we're going to say, actually, we don't need to nest anything. We need to check if 4 exists, and we can just use an iterator for that. We're going to say auto it is equal to find, and then m dot begin. And we're going to be looking for the value that we need. Actually, for a hash map, we can actually just do find the item that we need, and we should be good, I believe. So target is 7, and we're going to subtract 3 from it temporarily. So we're going to create a temp, and that's going to be equal to target minus nums at I. Then we're going to look for temp. And if it exists, if the iterator, it stands for iterator. I'll just name it iterator. So this is an iterator and this is an index. They're similar but very different. This one deals with memory with hexadecimals in the background, and this one is just like a subscript. Okay, so if it does in fact exist, then we can go ahead and get the or return the values that we need. So we're just gonna return. So they ask for the smallest one first. So we're gonna put the smallest one first. So here we would just say I, and then the iterator. Oops. Dot second. And that should be our answer. And then here we should never reach this point, but I'm just gonna return emptiness. We can probably try that and see if anything goes wrong. It says find temp. It doesn't like this one. Oh, that's because I need to put m dot find temp. Okay, getting 0, 0. Pretty sure the issue is somewhere here. Probably here. So we're gonna make sure that it's not the same as I, because they need to be different. Like it says here, I cannot equal J, so that's could be the cause. And now it seems like we're skipping some things. Okay. So we don't need, we actually don't need to subtract that. All right. We're going to go ahead and try against more tests and see if it works. Looks like it did. Great. All right, it's complexity. Okay, so this is the best case scenario. You can't get it any better than this. So that's pretty good. Um, so just brief explanation on this one. So here, numZI is 3, and that becomes what we're looking for. So we need to find the key in the hash map that has 3. So if you go back to the question, so 7 minus 4 is 3, and at index 1, which is this is 0, 3, and this is 1, 4. So at index 1, the key becomes 3 because 7 minus 4 is 3, as it says here. So the target is 7, and num's add counter here is 4, and that's going to be 3, and then this is just 1. So in that instance, then we get 0 because I starts at 0 and the first one is 0, which is 3. And then we just get the iterator second, which is the actual value which we're using counter as an index for. So the hash map, the key holds the value that we need to match with this, so like its complement, and then the index that belongs to that number. So that's the main thing on that one. So now we're gonna do group anagrams. Given an array of strings, group all anagrams into sublists. You may return the output in any order. Okay. An anagram is a string that contains the exact same characters as another string. The order of the characters can be different. So we are given this list of strings, and we are expected to group together anagrams and return them in a two-dimensional vector. Okay. We're just going to call this ans for answer. All right. I do believe we had a similar one. And how did I solve this one? I sorted it. Okay. So we could probably sort these as well, but we can't modify them because we have to return the original string. But we can create a copy. Okay, so we created a copy and we're gonna do is equal to strs, and that'll create a deep copy. So the copied values will not affect these, even if we sort these, it won't affect these. But here it's a vector of strings, so we need to sort each string individually for auto X and just copy. We're gonna go ahead and sort each of them. So we're gonna call the sort function x dot begin, x dot end. And now this should all be sorted, and it makes it much easier to just detect anagrams in the list that is, well, the copy now. And I'm just going to create that for loop. And here we are keeping track of this variable, which is our vector that we're given to work with. It's this one here. Here we created what we are going to return as the answer. So by the time we're done, we're going to say return answer, which is a two-dimensional vector. And this is a one-dimensional vector. This is also a one-dimensional vector because it's only linear. And we sorted all these strings alphabetically, or you can say lexicographically. And each one of these is sorted. So instead of this being cat, it'll say ACT because A is the smallest one. And then C and then T. So So to make this work, I'm pretty sure we have to nest loops, or we can create a hash map of the anagram, the sorted string, and like a tuple for each one. But I mean, we can just do the 2D vector as well. So we're gonna do size -1, and then while z is greater than or equal to I, and z minus minus. And since we already have them sorted, we're just gonna check with our sorted copy, and whichever ones are anagrams, we are gonna actually remove them from the list. So we can say and stop push back. Well, actually, no, we need to create a temporary vector here. Just call it a temp. And this is going to be added at the end. So after the for loop executes, we can go ahead and say answer push back temp, which will be our array filled with the items we need. And these need to grow dynamically, actually. Yeah. And that should work, hopefully. So here we can just look for items that match copy at I. So we're going to say if copy at I is equal, strictly equal to copy at Z. So if they're equal, we're going to go ahead and add them to our temporary vector. But we're going to add the items in STRS at that index. So we would just say STRS at the index that we want. Yeah, should be fine. And then from here, so typo there. We're going to go ahead and delete the item so that we don't have to add it again or check it again. So I'm going to say STRS dot erase. Actually, just say erase at strs dot begin plus z, I believe. And I think I remember correctly. It's this function uses the dot, if I'm not mistaken. Probably does. Yeah. And then we're gonna do the same deletion, but in copy. All right, and then once we're done with all of that, actually we can go ahead and add the first item to temp. We say temp push back. We're just gonna add I in there. STRS at I. And we're not gonna check I again because our loop is moving forward, so we don't have to worry about it, deleting it or anything. And I may be calling early, but I just want to check for syntax mistakes because it's looks like a lot. It looks like it's already working. I'll try it again. And yeah, it looks like it worked. I did do most of these problems yesterday morning. Just this is more than anything a refresher for me. Um, and yeah, looks like it's already working. So basically, what we did, we created a copy, like I mentioned, and we sorted each string in the copy. So we copied this in a separate memory location, and then we sorted each one of them, and then we started iterating from the start to the end, and we got the first item in the copied list, and we checked if any other of the items matched. And if they did match, that means they're an anagram because they're sorted and they have the same amount of letters. So after that, we basically inserted the copies into a temporary vector. And then once the vector was filled with all the anagrams, including the I, which is what we're using to compare at each iteration, we went ahead and placed that vector as so, like this. We placed it into our two-dimensional vector up here, answer. And we also erased the items as we were adding them to avoid checking them in the future. So if we are checking act, and then in here we reach cat, we add cat to the temporary vector that we created, and then we delete it from the list so we don't have to check it again once we're checking pots against like tops or stop. So next time I'll only have to check stop and tops. I won't have to check hat and cab because I already used those before. So it gets smaller, ideally, every time it finds something that is an anagram. The amount of checks that we have to do in the next round of iterations gets smaller and smaller as we get closer to the end. So less computation the closer we get to the end. Just to clarify. Okay, so the next one is this one. And this one, it says, given an integer array nums and an integer k, return the k most frequent elements within the array. The test cases are generated such that the answer is always unique. You may return the output in any order. And here's an example. So, okay, so k is an integer and it wants the k most frequent element. So 3 is the most frequent and 2 is the second most frequent. So 2 and 3 are the two most frequent ones. And then here it only wants 1 and we only have 2 instances of 7. So it's 7. And the constraints are that the length of nums is from 1 to 10 to the power of 4 included. And then each item is either negative 1,000 or positive 1,000. And then, so this can be a huge, very huge list. And the numbers in there can only be in the range from negative 1,000 to 1,000. And there's always going to be one or more k distinct elements in nums. So for this one, honestly, we can use a hash map to keep count of the biggest ones and then use an iterator to track which ones are the biggest one and then delete it from the map k amount of times. So that's what I'm going to try to do. Yeah. So our map is going to be int again for the count. And we're just going to name it m. I'm going to do auto x in nums. And then we're going to fill this map with the count of each element. So we're going to say m at x. And then when we reach x, we're just going to increment it. So each time we repeat the same value, we're going to increment the counter. And with that, we already have a hash map with each element and each element's frequency of appearances on the list. And now we're going to do another for loop. Okay, looks like there's a typo there. So now here's where we're gonna go ahead and check to find k amount of things. So we're gonna go ahead and do uh, it, and we can use max element, which should help us find the max element. So that'll help us find I believe the value is max element. I believe so. I might have to go with that. Okay, so it's gonna find actually the key. So we're gonna use the third parameter and just use lambda for this then. Yep. So we'll use lambda, we'll say constant, then auto, by reference A, same thing for B. Here we're just gonna say return A dot second, and then compare that with B. Because when you pass two elements into it, it knows it has to compare them. So we're just returning that customized parameter. So that should find the second. And a hash map second is the value, which is what we're trying to compare the amount of occurrences that are happening. And that should be it for that one. So now we just need to add that to our answer. So it's expecting a vector of all of our answers. So we can just do, or a list of all of our answers, not necessarily a vector. So now we're going to go ahead and add it to the actual answer, but it is an iterator. And just for good practice, we're going to make sure it's not out of bounds. So m.end. And then we can go ahead and say ants push back it. Since it's an iterator, that'll give us an error unless we dereference it, and then we can say k minus minus, and we should be good. Then here we're just going to return answer, and we can go ahead and try that. Looks like unordered list. unordered map. Okay, so there's no matching function for the vector. That's interesting. I do believe we can also do the this type of pointer. That should work. But we need second. Let's see. Looks like the second one is wrong. It's because I forgot to remove it. So I'm gonna do erase. Should be m dot erase, and then m dot begin, and then plus. Uh, Actually, we can just pass it since it's already an iterator. Okay, great. That one was a bit interesting. But essentially, we use Lambda to customize the definition of this max element function, and we use the iterator from the max element to dereference the actual value that we needed, which is the key, and we added it to our answer vector, and then we deleted it from the hash map since we're not going to reuse it, and we decremented k, which is the amount of big items that we wanted, to avoid repeating the same one over and over again. And that's it for this one. To know uh, this one, encode and decode strings. Design an algorithm to encode a list of strings to a single string. The encoded string is then decoded back to the original list of strings. So this is two functions. So we are given an input and they have to decrypt it. And it's an input of strings and it has to be decrypted back into the strings. Okay. So this to implement in the real world is pretty complicated. You need to do things like checksum, networking, TCP, and um, UDP protocols. But for the purpose of this function, at least to match the specification, we can simplify this to just the basic idea of what it is. So what I'm going to do is it's expecting for me to return a string in this one. So I'm going to create a string, call it S for string. And I'm going to do something, I'm just going to keep it very simple. What I'm going to do is S, and then we're going to add a character. We'll just do this character. So we're only going to do this once we're at the end of a string. So we're going to add first X and plus that, where X is a string on its own. So we're essentially concatenating two strings together. So this string plus the new string, and then we are separating the next instance by that character. And then we can just return S. And once we get here, all we have to do is essentially remove that string. So this one is expecting a vector. So here we're going to go over the string. And once we hit this character, we're going to go ahead and know that we're at the current next string. So if X is equal to this character, then we're going to go ahead and just cut off the old string. So to do this, the first thing that comes to mind that seems ideal for this is a temporary. So temporary string. Okay, and then from here, we're going to go ahead and add what we have to the vector. So we're going to say ants dot push back, and then that's going to be temp. And then right after that, we're going to go ahead and clear temp. So I'm going to say temp is equal to empty string again. And we can just ignore that little character. I'm not going to add it. Then we can just return answer. Okay, looks like I have empty strings. And I'm including that little character there. Okay, that's because I'm just adding this here. Okay. Can move it at the end, and that should work. Oh, now I moved it to the other side, right? Yeah, definitely. Okay, so I think a better thing to do here for that would just a quick if check. Or even better, just an else. And it looks like it passed all the tests, so we should be good. So I was also did that one. Um, and I mean, I can do the rest of them tomorrow or something. But thank you, appreciate it. And real quick, just to recap what we did, we went ahead and solved 1, 2, 3, 4, 5, 6 problems. We created two functions in this one, and then we got the top most frequent elements in an array. We grouped anagrams together. We did the two-sum problem, also the valid anagram and the contains duplicate problems.